Hi everybody, so here are some videos just looking at IR spectroscopy. You guys have asked me for a couple of those. This is kind of weird because all I'm really going to do is show you what I do when I look at an IR. There's no real video for me to make about it other than just showing you what my techniques are when I approach this. So this series of videos is just the peaks I would look for and the assumptions I would make based off just IR spectroscopy. Alright, so most of these videos are going to be broken up, but as you can see on the left panel here, these last 4 videos I'm going to combine into one video at the very end because they kind of go together. But these are just individual ones, these first few. Alright, so I know that some of you guys have found this website, so this is something I took online. This is not a problem that I generated, so I don't know the answer to the problem, but I'll show you how I approach this. When I have IR, the first thing I'm going to do is I'm going to mark that line at 1500. I'm going to go to 2000 and say this is my SP2 region. Then I'm going to go to 2500, and that's going to be my SP. And then everything to the left of that is going to be my hydrogen region. So if I have a hydrogen in the structure, that peak is going to show up here. All right. Okay, so with my SP2 region, that's where I'm going to expect to see double bonds. Now I'm noticing a very, very strong signal here that's very narrow. And for me, I'm going to check to see if it's close to 1700. So this is 15, here's 16. It is close to 1700. So I'm pretty confident this is going to be some type of carbonyl. And I can go ahead and eliminate C and D. I could have already eliminated D because I don't see a nice broad peak that would be indicative of an alcohol. I can go ahead and eliminate E as well because I would also see a broad peak that might have some edges to it on the right side. So I can go ahead and eliminate those, and now I'm already down to just 2 structures. So I'm down to A and B, which is just 2 ketones. So that carbonyl isn't going to help me because they both contain it. But what will help me is the benzene ring. So there's a couple of ways to go about this. One, I could just look for the benzene ring. So I see something. I see these peaks here. I have this strong peak there. So this tells me I have a carbon-carbon double bond. So B is definitely my structure. But if you're someone who kind of struggles with finding that benzene ring, these peaks right here would have also told me that benzene was present. Another number I mark off is right at 3000. If I have peaks below 3000 like I do here, these are going to be hydrogens that are bonded to an sp3 hybridized carbon. So A and B both have those. So we have these sp3 carbons, and then you have these here. But what B has that A does not is it has hydrogens that are on sp2 hybridized carbons. So if it's on an sp2 hybridized carbon, that means it is on a carbon that contains a stronger bond. So that's going to shift my peaks to a higher wave number, and that's what these are right here. So these are going to be hydrogens that are bonded to an sp2 carbon. So that's another way I could have verified that the benzene ring is present. I could have looked for the carbon-carbon double bond peaks. I could have looked in the fingerprint region for benzene, or I could have just recognized the fact that I'm going to have sp2 hybridized carbon hydrogen stretches. So I'm pretty confident the answer here is going to be B.